All right, hello everybody. Welcome to Reimagine 2020. We have an exciting workshop for you today. We have Dan here from the NEO team. I don't want to take up too much of your time, Dan, so go ahead and kick it off if you'd like. It looks like we have some attendees here. Feel free to ask questions. This will be recorded, and it will be under the NEO workshop in the Reimagine 2020 website if you haven't registered. It's free access. You can see Neo's interview as well. There's a recording there, and then you'll also have access to the workshops. So go ahead, Dan. Go ahead and kick it off. Thank you for joining us.
Awesome. All right. Hi, everybody. My name is Dan Byrne. I'm a software engineer here at Neo1. I've been here for about 2 years, and we are very excited to show you guys kind of just like a quick run through on how you can get started with our whole development platform working on Neo. So I'm going to do a quick few slides on just like kind of background about Neo and Neo1. Neo is the blockchain itself. So Neo is sort of unique blockchain in that its consensus mechanism is delegated Byzantine fault tolerance. What does that mean? It basically just means that it gets quicker consensus, and it gets almost better consensus than what you would get from like a typical blockchain like Ethereum or Bitcoin. So, you know, in Neo, it's just, you know, you need like three-fifths of it's like half plus one of the nodes to agree on consensus for, you know, a block to be produced. Whereas Bitcoin and Ethereum will have different systems that maybe offer different things. But one of the main benefits to delegated Byzantine fault tolerance is that we're allowed to, we get one block finality, which is super important. So when a transaction is made on the Neo blockchain, that transaction is final. Like there was some like brief forking going on in the early days, but it's not a non-factor anymore. So one block finality is basically one of the main reasons that we at Neo1 feel very strongly about Neo as the best smart contract blockchain. One of the other benefits is that it is a UTXO and a smart contract blockchain, which means it has native assets as well as your typical like NEP5 assets. And the other main kind of factor drawing us to Neo is that the block times are 30 seconds typically, and that is like way faster than any other blockchain. I mean, there are some that are quicker. So like EOS, for example, actually has quicker times, but it does not have the one block finality as well to back that up. Moving over to Neo1. So Neo1 is a complete end-to-end development framework where we kind of try to handle everything involved in building a smart contract, testing a smart contract, deploying it to a local development network. We'll start up an instance of Neo Tracker so that you can explore your local private network that we've set up for you. We use that. Everything that we do is in TypeScript. You can actually just use plain JavaScript if you want, but for building a smart contract, we'll use TypeScript. And that allows us to use a lot of the built-in features for TypeScript, especially the compiler. Whoops. And we also offer a whole suite of courses, documentation, and additional tools, namely in like, you know, the node side of things. If you want to run kind of your own private network locally, apart from, you know, like Neo1 can be used for more than just smart contract development. Although that is like our main focus right now in what we're promoting, it also just offers a whole slew of client APIs you can use if you just want to interact with the Neo1 block, with the Neo blockchain. So real quickly, I'm just going to go through kind of a quick workshop. It shouldn't take too long, maybe 40 minutes from here. But we're just going to kind of go over getting started with Neo1 and what you would do if you wanted to start building a contract today. So let me close this for now. We will get started. So here I have just a quick kind of repo that I've set up with some basic features, and it has a git ignore. I set up a quick just config for testing later. You can see my package JSON. I've added these 5 Neo 1 libraries, which will be important later. I'll kind of go through each one of them, but the main one that we're going to be interacting with is the Neo 1 CLI. It's going to allow us to run a lot of the commands to get started. Some other things I have in here real quick, just a basic tsconfig. You'll see this exclude line. This actually gets added automatically by Neo 1 when we run it. And then that's it. So from here, we can get started. Over here, I'm going to clear this out. And we're just going to run our basic command for initiating a Neo 1 repository, which is Neo 1 init. So we run yarn Neo 1 init. It's going to build up some quick kind of files for us. So we'll take a look through each one of these. So here we have the Neo 1 config. This is a bunch of basic, just kind of like output paths. So like this one is where are you writing your contracts? You're going to write them in Neo 1 smart contracts or Neo 1/contracts. So like here's an example contract there. We'll get into that. These other things, you know, this stuff isn't super important at the moment, at least for the use of this workshop. Like we won't be going into these. The code gen paths, again, it's just kind of path setups. If you're using a front end framework, you can define that here. I don't think we'll have time to get into putting a front end on this code in this workshop, but we have tutorials and courses on how to set that up on our website. And then this is just kind of some standard, you know, where we're going to start a Neo 1 network. This is where our Neo 1 node is going to start and where it's going to store some temporary files. And then here we have some networks which are used for deployment, which will come up later. And then we also have the option of starting a NeoTracker instance on our local private network. I'm actually going to turn that off for now. We might turn it on later in the tutorial, but for now I'm going to leave that off. And that is it for our Neo 1 config. And then if we look at what other files we've generated here, we have a tsconfig, which is pretty standard. You'll notice that in our base tsconfig, we actually exclude this contracts library so that this is the tsconfig that gets used when you're inside of your contract. And then you'll also see in contracts, we have this hello world example contract. It's just really cookie cutter, you know, it has one function called hello, and it creates an event for that, and it returns it. And that's the whole thing. And here's an example of a quick test. You'll notice that this cannot find it because we actually haven't generated it yet. So to generate all of the helpers that we're going to use for testing our smart contract and to deploy our smart contract to a local private network, we're going to run yarn Neo 1 build. Yarn Neo 1 build is going to do a few things. It's going to start with it's going to start up its own development network. So you're going to see over here, we have Neo 1. This means that a Neo 1 node is now running, and we have a network, and it's running its own consensus. And we've also set up some wallets. So we'll have some helpers here. If we add this here, you know, we can add kind of account IDs to our test. And this is just a whole array of wallets that have different amounts of money so that you can test making transfers and transactions. Right after that, we're going to deploy our contract. If you have larger contracts, this is a little more clear onto what's deploying. But because Hello World's so small, it just kind of instantly completes and deploys it. And then we're going to generate a bunch of common code. And this common code is going to be located in source here under source/Neo 1. And you're going to get a whole bunch of different things. You're going to get a client. This is where some of those wallets I was talking about before are defined. You're going to get kind of some contract code. You're going to get this test code, which is what we'll be using mainly for this tutorial, is this, you know, with contracts code. And then you're also just going to generate, you know, all your basic Neo smart contract utilities. So you have, you know, your contract, your ABI, and then some types to help you with that. So following off of that, we can kind of walk through this Hello World contract. So if I run the test for Hello World, you'll see it passes. All we're doing here is we are kind of calling the base function and then making sure that it returned successfully, and then we're checking that it equals what we're expecting it to equal. To walk through this tutorial, on how to build a token, though, we're actually going to completely ignore our hello world contract, and we're going to start our own contract. So I'm going to go to the contract folder. I'm going to make a contract called token. And I'm going to make a class. So all smart contracts are going to be of the same class, and they're going to extend our smart contract definition from Neo1 smart contract. This just has some, a lot of what this does is just add helpers for our compiler when it gets to that. We have a lot of kind of hooked up built-ins and stuff, so you're going to see a lot of imports coming from Neo1 smart contract in this regard. So to get started, though, we'll just start like this is the basic contract. This is as small as you can write a contract in Neo1. It's a contract, and it exists, and that's about the extent of it. So if we want to make a test for this, we'll go to our test folder, make token.test. And then this test, we'll just make sure that it exists on the blockchain. So to do that, we actually need to go ahead and build our token first. So we're going to go ahead and run build again, and this is going to deploy. Now it's going to build and deploy not only Hello World, but also our token contract. So you'll see we have now some token files also generated in our generated source folder. So with that, we will be able to use this with contract helper, which is generated for all of our contracts. And what you're going to want to do is, let me import it. So we're going to import it from there, and then you're going to want to access it like this. So basically what this is doing is this is starting, it's connecting to the development network, kind of resetting the network, and then it is giving us access to our token and all of the helpers that come with that. So what we can do here, just to start, is a basic, since we have nothing in our smart contract right now, the basic test we can do is just expect it to be defined. So we can run this, expect token.toBeDefined, and you'll see that run this test. Successful. The token exists. One of the caveats to testing a smart contract in Neo1 is that each test, in each time you call with contracts, is going to restart the node and do a lot of initialization. So in a standard unit test outside of Neo smart contract land, you would typically break your tests up into multiple subtests. So you would have this test, and then you would say, okay, maybe I'm going to test one property, and you would have another test for a property. This can actually add a lot of downtime to your tests, because as you can see, even testing that this contract exists took 3 seconds to run. So basically each unit test you add will add that much time to it because of the amount of work that goes in before actually running the test. So what we like to do is just, even though it's a little messy, is to just kind of have one long test function that will test every aspect of your contract. And you can still organize it pretty easily, regardless of that. So let's add some properties to our contract. So the first thing we're going to add is a name. Adding a name is really easy. It's just like writing a normal a normal TypeScript class. You're going to have a public read-only name. We'll call our token Eon, opposite of Neo. Well, I guess it's not the opposite. And then we'll add a symbol, which is just all caps Eon. And then we'll also add this property called decimals. So decimals is going to be the number of decimal places we represent numbers with in this smart contract. So the way it works is that in every smart contract, all numbers are represented as full integers. That being said, you can still represent decimals, using our client APIs, etc. So we'll have this decimal places here. It's not going to be super important, but basically all this tells the the user and the client about is how many decimal places that numbers need to be converted to when going in and out of our smart contract, if that makes sense. It'll become more clear when I make an array storage. So that being said, this is also super kind of simple properties, but we're going to go ahead and test those either way. So we're going to run yarn neo1 build. It's going to regenerate our contract, redeploy it, reset our test network. And then when we come here, we're going to be able to kind of access those properties. So the way we do that is through a promise. So I'm actually going to represent all of these as a promise. So we're going to have const name, symbol, and decimals. And we're going to set those equal to the result of this promise. So we'll have promise.all, and we'll say, all right, we want to get the token, and we want to get the name. We want to get the symbol, or sorry, we want to get the token, and we want to get the symbol. We want to get the decimals. The reason that we access all of these properties through a function here is because everything is an invocation at the end of the day. Like when we generate our client helpers, even though this is represented as a normal property in our contract here, the helpers that actually fetch this are going to be functions that return a promise. So we need to await those. So we do that here, and then we can just kind of check those like you would in a normal jest test. So we'll say expect the name, to equal eon. We can expect the symbol to equal eon, and we can expect the decimals to number to equal 8. The reason we use this to number helper is that every number that comes out of a smart contract is going to be represented as a big number. And so you're going to want to use the built-in helpers to get that back into your normal kind of JavaScript representation of it. So we can run this test now. We'll run yarn jest token.test.ts. And we should see that it passes successfully. Cool. So with that, we're going to just continue adding features to our token contract here. So we've got these figured out. Now this is a token contract, so we're going to want to add some kind of way to store how much tokens a certain address has. So we're going to do that through creating some storage. We have a bunch of options for storage in Neo1. The one we're going to be using today is called map storage. So we could have another caveat about storage is that any storage needs to be read-only. I guess it doesn't have to be read-only, but it is always going to be better to access your storage kind of through a function than it is to try to access it just as a property. So we'll have this kind of read-only balances, which is a map storage. This map storage is going to be imported from Neo1 smart contract, and you're going to see that when you create it, you're going to have to define the types that you want to make this storage for. So the types that we're going to be storing is we're going to be storing basically a map of addresses to their balance. So we'll have an address here, and we'll also be mapping that to a balance, which is a fixed 8. Let me get fixed imported. I don't know why this is not importing properly. And this is back to the decimals point. Like, we're just saying that this is a fixed number with 8 decimal places as a representation. So that's all you need to do to create a balances storage. We'll also have this private method that is not storage. It's just a constant. It's just a number that will keep track of how much of our token that we've handed out. So this is, again, is just a fixed date number because everything that we use is every number we use in this contract is going to be considered a fixed date. So yeah, those are our two storage kind of constructs we're going to use in this tutorial. So let's add some getter methods for those. So we're going to import this new decorator called constant from smart contract. So what a constant function in a Neo1 smart contract is any function that doesn't touch, that doesn't alter the smart contract property. So essentially anything that doesn't need to invoke and submit a transaction to the block. If you have to wait for the next block, or if what you're doing is going to like alter the smart contract in the next block, then you can't make it a constant function. So for example, getting the supply of this contract on this block is a constant function, but making a transfer of tokens, which will, affect the storage in our balances property here, that cannot be a constant function because it's going to actually affect storage on the blockchain. So we're going to add this constant function here, and we're going to add a total supply getter. And all this is going to do is return our mutable supply. Just like this. And then we're also going to add another constant function, which is just going to return the balance of a certain address's funds, on this block. So we'll have the balance of function, and this will take an address. And it will return a fixed date. So what we want to do here is, so when we're accessing map storage here, every lookup we do could possibly be undefined. So if we look up this address, it's either going to be a fixed date number or it's going to be undefined. So what I like to do is I do, maybe balance is equal to this dot balances get. And this is how we're going to access our properties of this map storage. And then we're going to try to get the address. So you'll see we can kind of get the inline help here that this is either a number or, well, okay, so this is a special type that lets us, that we use internally. So you don't really need to worry about what this combined type is, but basically it's either a number or we get undefined. So if we get undefined, we just want to return 0. So we can return a normal ternary expression. If maybe balance is equal to undefined, return 0, else return maybe balance. And that's all we need to do to return the balance of somebody's tokens on this smart contract. So once again, we'll go back to our tests and we'll kind of test these properties. I'm going to run yarn Neo1 build again, kind of build those new properties we just added. And then down here, I am going to kind of add a few things. So first thing we need to add is we need access to those wallets that we set up over here in the setup wallets section. So this is going to be, this accounts ID here is just going to be a whole list. I want to say it's 10 accounts with different amounts of coins in them. I think it goes from like 0, 1, 10, and then it just kind of increments of, powers of 10 from there of like how much Neo and gas they have. But with those account IDs, something we can do is we can say, okay, here's the wallet I'm going to use to test, or here's the account I'm going to use to test. Let's just call it wallet. Wallet will be our just kind of the first account in this array. And then what we can do is we can fetch the total supply and the balance of this account. So we'll do the same thing as before with like we do with a promise.all, and that everything we fetch is going to be a promise, so we need to await it. So we'll have total supply and balance is equal to the result of this promise. And this promise is going to be token.total supply and it's going to be token.balance of wallet.address. So this wallet has a few properties on it. Well, actually, it has two. It has the network that it's on, and it has the address. So we're just going to use the address to fetch this. And then, just like we did before, you can do a normal just test here. We expect that the total supply, since we haven't done anything, remember we have to switch this to a number. Since we haven't actually distributed any of our token yet, we expect this to be 0. And we can expect that the balance we get for a address that hasn't gotten any of our EON to also be 0. So we add those tests in, and we can go ahead and run the test again to show that that still works. And we pass. Cool. So now we have a contract that has kind of, some representation of balance and total supply. Now we want to actually, before we add how to transfer and mint these tokens, we actually need to add one more quick thing. So every smart contract has a default constructor, but you can also define one. And it's kind of important to do that. You don't really need to for your simple local testing, but something that's really important as an additional check, doing something like this. Let me write ahead a bit, and I can explain. So in our constructor, everything needs to be initialized with defaults as a value. So we're gonna basically add a property to this token contract called owner, and the owner by default is going to be equal to the address that deployed this contract to testing. So by default, it's going to be the first account in our account IDs from test. So this account right here, I think I'm almost positive that this is considered the master wallet. So this is going to be the account that is deploying this contract by default here. But in the future, when you're deploying somewhere else, or if maybe this is a template contract that other people are going to use, this value might change. But it is important that you add this here, because then it allows you to do some other helpful things. You can do a check to make sure that the person who called deploy on this contract is actually the owner of this contract. The difference might be a little unclear, but it is important to make sure that when I created this contract and tested it, and then I deployed it, maybe I didn't expect that I was actually deploying it from another account and I forgot. You want to make sure that the owner of it is also the one that deployed it. So it's pretty easy to do here. You can just kind of throw a new error. If the address, if the caller of this contract is not the owner, then you can just throw an error because somebody else is trying to construct this contract. Sender was not the owner. Cool. So that will just be an extra constructor check that we'll use later on when we want to, let's say you want to add a function that kind of like cashes out this token where, let's say we had 100 people who swapped some NEO into our EON token, and then you want to add some functionality so that only the owner can actually collect that NEO and transfer it somewhere else. This is where this owner property becomes really important. Cool. So with that constructor done, we can move on to adding a transfer function. The transfer function is going to be pretty simple. Basically, we're just going to have a from address, we're going to have a to address, and then we're going to have an amount that you want to send. So the amount is going to be a fixed date, and then it's going to return a Boolean. So something I haven't really touched on is the difference between what a good response type is here. Because like, for example, a transfer function, it just does the transfer. There in a normal TypeScript class, maybe this would just be a void and you wouldn't return anything. It would just run the transfer, and if it throws, then you know something's wrong, and if it doesn't throw, then you know it was successful. That's kind of different in our smart contract setup. You want to return true on either true or, like in the example of balance of and total supply. You know, you're returning an actual value, but you want to return from your functions here. So the standard we use is that you want to return false if it's an action that maybe they can't do. Maybe, you know, maybe someone wants to transfer some tokens and their account doesn't have enough to send that. Then you want to return false. If, for example, the amount that they are asking to send is less than 0, then that is considered kind of like a really extraneous case where you just want to throw an error. Like if it's a real error where it's totally out of bounds that you would even try to do this, then you want to throw the error. So for here, let's say the amount's less than 0. We want to just say that, hey, the amount needs to be greater than 0, and then we'll actually give them some information on what was submitted. Cool. And then, you know, so then an example of where you would return false is like, let's say that the person who is calling this transfer function isn't actually the person that we're saying it's from. So this call right here is basically just to stop people from anybody from being able to transfer your funds for you. Essentially, this makes sure that only if the person calling this transfer function is the person that we're saying it's from, do we allow them to even go through. So if it's not, then we just return false and say you can't do that. All right. So now we're to the point where we want to try to make this transfer happen. So we'll get our balance using our internal balance of function, and then we'll check to see if they have enough to make this transfer happen. So we'll say from balance. If that's less than amount, then again we just return false because you can't do it. So I hope the distinction on where we're throwing errors and where we're returning false is pretty clear here. Like this amount less than 0 is a total like nonsensical call to this transfer function, whereas, you know, the transfer function not being the same caller as who it says it's from is, you know, valid. It just you're not allowed to do it, so we should return false. So then finally, let's say, you know, we get past this if statement check here. So now we know that from balance has enough to make the transfer happen. So we can just quickly get kind of the balance of the address we want to send to, and then we can just set those balances. So we're going to use set property on our map storage. So we're going to set the address of from to the from balance minus the amount, and we're going to set the to balance, the to address, to be, you know, its previous balance plus the amount that we just moved from this address. And then since all of that should be successful, we return true. Yeah, this is what a pretty basic kind of transfer function is going to look like. And this is only for transferring this Eon token. This doesn't involve Neo yet. We're actually going to move before we get into testing this, because before we can test transferring Eon, we need to set up a way for people to get the Eon. And so that's what we'll kind of move to next. So we have this transfer function. That's great. We also are going to need a way to give people coins. So we're going to make an issue function. And this will basically just be a function that adds Eon to our total supply distributed and also puts it in a balance given here. We're actually going to make this a private function so that APIs aren't generated for it. This will only be used by the smart contract. So, you know, this function will take an address and it'll take an amount. going to return a boolean. And then all this is going to do is it's just going to set. Since this is only getting used internally, we don't need to be as extraneous with our checks. Oh, and actually another thing is that since this is a private function, we actually don't need it to return anything. That will get handled elsewhere. Whereas before here, like this public transfer function needs to return, or is expected to return a Boolean. It's not as much of an issue when you have a private contract because nothing is getting sent back to the client on this. So anyway, we want to set the balance of this address to the balance of the address plus the amount that we're saying we're issuing. And then we also want to increment our total supply. Cool, so that will be our issue function. And then finally, to be able to use this issue function, and the way we're going to use it is by exchanging Neo UTXO for our Eon token. And we're going to do that through a function called mint tokens. So we'll have this public function called mint tokens. And this is actually going to be another function that has a special decorator. So we're going to import this decorator called receive. And what this does is this marks mint token as a function that can take Neo input and output UTXOs. So for example, when you make a call to this Eon contract, you'll make your invocation to the mint token, and you just attach the amount of Neo that you want to kind of exchange. So the way this works is we kind of get all of the references and the outputs of the transaction from the blockchain. So we're going to import this blockchain helper from Neo1 smart contract, and we're just going to get the current transaction. So at the time of calling mint tokens, we're going to get what transaction we're at. We're going to make sure that there are references in this case is just kind of like your list of kind of addresses that are that have inputs and outputs on the transaction. So this is kind of like this is just like the corresponding inputs and outputs of this transaction. So here we're just going to say, if we don't actually have any references, then we return false. We don't mint anything. Going further, we can, if it's not that, then we know that the sender is going to be the first reference in this list, and we're going to get its address. So let's say you call mint tokens on our contract and you submit it and you give it some Neo, and then we're going to just kind of take that transaction. We're going to look at the sender on the transaction. We're going to get the sender, and then the next thing we're going to do is we're just going to kind of go through the outputs that are on the transaction, and we're going to collect those and then essentially add them up and call mint token on them, while also because when you are calling this mint token, you're sending Neo to the contract address at the same time as kind of calling this function. So we're going to have this amount. We'll set it equal to 0 for now. We're going to iterate over all of the outputs on this transaction. And then we're going to check. We're going to say, okay, if the output here is trying to go to this contract address, and we know that they're trying to exchange this output for our token, and then we're going to double check that this output that they're trying to send us is Neo. The way we can do that is another helper function that we import called hash256.neo. This is basically just, I want to say it only has Neo and gas on it, but it's just the hash of the UTXO asset. All of this will actually change coming soon in Neo 3.0 because we're using it here. But for now, this is how you would do it to transfer Neo. So let's say, they don't send us NEO. Maybe they sent us gas because they thought we exchanged gas here, but we don't. We returned false. And then assuming that they did send us NEO, then we're going to want to add that NEO. We're going to want to add the value of that output to our amount that we're going to kind of add to their balance. So we go through all of these. We go through all of these outputs. We collect all of the NEO outputs that are marked as being sent to this contract. We add them all up, and then finally, we're going to call our issue function. We're going to issue them the amount that we calculated, sending it to the reference that sent it. And then after that's done, finally you can return true. So this is where I was kind of saying that it's not important that this private issue function returns a Boolean, because when we use it, we're going to return a Boolean either way. We're sort of running low on time, so I'm just going to kind of quickly run through how we would test this. So once again, you're going to want to run yarn neil1 build. And that should be successful. And then we're going to kind of come back over to our test where we can add some kind of functions to mint some tokens. So we're actually going to get a new wallet here. We're going to make it the account IDs 2 wallet. This has, I think, 10 NEO in it. And then we're going to say the amount that we want to send in this mint is we want to send 10 NEO. Again, we're going to have to import this big number because that's how we represent numbers in our smart contracts. And then, so to mint this, since this is not a constant function like it was before, we kind of have to go about things a different way, because we have to wait for the consensus to run and the block to kind of, to run its course. So the way this will work is we're going to have a result from minting, mint tokens result. And this is going to be us, it's still a promise. You're still going to run, mint tokens. And like I said before, since this receive decorator kind of adds some special properties to mint token for us, it's going to add this send to and this from property that we're going to want to add as arguments. So the send to is just going to be a kind of list of where and what assets you want to send. Or sorry, the amount and the assets that you want to send. So we're going to say we want to send, the amount here, this 10 NEO, and the asset we want to send is, again, that hash 256.neo. Let's import this. And then you're also going to want to be sending that from the mint wallet that we defined before. And all this is explained pretty in depth in our online courses and tutorials onto where these default arguments are coming from when we add this decorator. So you can look there if you're kind of confused about what's happening with this function. But essentially, you're going to call this, and then you're going to wait for it to confirm. So every function that isn't a constant function is going to have kind of this special dot confirmed property on it. And what that's going to do is it's going to allow you to wait for kind of the block to finish processing. So you run mint tokens result dot confirmed, and this is just going to wait until the mint token function is actually finished calling and has run. So we wait for it to confirm that it actually got posted to the blockchain, and then we're going to do a quick check on kind of the state of the contract after this. So we say, okay, mint tokens receipt, it gives us a result. We're going to check what the state of that property is. In Neo smart contracts, you either have fault or halt. So if it's not equal to fault, then we expect that it returns true. And then if it's not fault, then we expect it kind of to equal halt. So this is actually just kind of like a quick fail-safe way to throw if it is equal to fault. Basically what we're doing here is we're saying, okay, if the state of this call is fault, then we're going to check this, even though we know that there's no way this is true because the smart contract errored on our invocation. So then what we are really expecting is that the state is equal to halt. And then finally, what we can do is we can say, okay, let's get the total supply again, and let's get the balance of this mint wallet that we just added our token to. We're going to again do the same, basically the same thing that we did here. I actually need to, I'll call it something else. I'll call it after supply, and we'll call it mint balance. We're going to do the same thing, token.total supply, we'll leave that, and we're going to do token.balance of our mint wallet .address. And we expect that our after supply, after we've minted these tokens, we're going to expect that to move to 10. We've added 10 NEO to our total supply, or we've added 10 EON to our total distributed supply. And then we expect the balance, or sorry, the mint balance to number also equal 10. And so we'll just run that test. We'll make sure that it equals 10. And we also get a success. You'll notice if you're running this locally, you'll notice this detect open handles warning. I think what this is that because we're running a network kind of outside as an external process that just isn't like, it's kind of hacky the way that we're using our local development network. So sometimes this will leave open. If you actually run this jest test with detect open handles, it will not detect anything because it does actually close. It just doesn't do it as quickly as jest is expecting. So yeah, going from there, you could really easily test this transfer function now that we have tokens. I don't think we're going to have time, to go on from here. But we have all this documented online. You can follow that. And then essentially all you want to do is you want to do what we just did, get 10 EON onto an address. And then you want to, run this transfer function from that address and then send it to another address. And then you can do the same, the same kind of testing we just did here. You're just going to check that, okay, the supply didn't change because we just moved hands. And then you're going to check that the balance that we sent it from is now equal to 0. And then you're going to check that the new balance we sent it to is now equal to 10. So yeah, that's just a real quick kind of 45-minute introduction into how you can get started on Neo1 with testing and running your own local development network. A few last things I'll kind of go over. If you want to get started, there are a few ways to start. You can go, I would personally recommend, if you want to get started on the Neo 2.0 chain and writing your own smart contract now, I would go through all of our kind of online tutorials. We have full courses laid out. You have a full online editor. We set up everything for you. You don't have to do any npm installing or node installing or troubleshooting like that. It's all online. It's really fleshed out tutorial. So I'd recommend going through that to just kind of get through all the basics. And then finally, when you want to start, using it locally, like I was just demonstrating, these are basically the initial steps you're going to want to run. There are a few more libraries besides just the CLI you're going to end up wanting to install. But we have all that detailed on our website. There's a full section of our documentation called node environment setup or just general environment setup. But we do try to walk through everything as easily as we can. And then to briefly touch on kind of like what our plans are for the future, our current goals are Neo 3.0 support. That is like our #1 priority going forward. I would say in the next month to 2 months, you can expect to see kind of preview Neo ones going up, and more work being done in our GitHub repository on that end. We also are working to add support to the kind of Neo toolkit debuggers. We're gonna try to work in as much documentation as we can, and to flush that out, because I know we get issues all the time with people who are just kind of confused and are lacking direction on what they need to do to to build the the tools that they're trying to build. So hopefully our documentation, I feel, is pretty fleshed out, but it could definitely use some work. So we're going to try to work on that in the future, and also keeping it updated, because we do typically tend to fall behind on like updating our documentation alongside our code. And then some other fun features we're going to be working on is like a standard library for contracts. So much like I exported a token class that extended smart contract, you could maybe export a token class that extends an ICO template token, so that all of those transfer, mint, issue, all of those tokens are already written and built for you, and you just kind of like go off of that and add whatever additional features to the token that you want. Compiler optimization is also in the work. One of the main things that we do at Neo1 is try our best to always keep up with the current TypeScript release and what we offer in our smart contract. We want to make sure in our apart from just trying to keep releases up and make sure that the compiler works, the main thing we strive for at Neo1 is to make it so that when you write a smart contract in TypeScript, you're really writing in TypeScript. You're not writing in TypeScript with a bunch of caveats of things that you're not allowed to do. We really want it to be as close to your typical kind of developer experience as we can. I don't think we have time for questions, but if you do have a question, my email is linked below, daniel.byrne@neotracker.io. We have a GitHub repo with tons of issues. We would love to have people come add issues or open PRs. We're super friendly about open source. We can help point people in the right direction. We are sort of limited on our development team right now, so maybe the amount of help we are going to be able to give on any particular issue, if it's kind of outside of what we're working on, might be limited. So PRs are super supported, and we'll try to kind of put people in the right direction. So yeah, you can open up any issue you want on GitHub. Let us know what you think. We have a Twitter, Neo1Suite. There's my Twitter as well. I barely check it, but if you want to tweet at me, I'll probably take a look at it. And yeah, I think that's it for my presentation. So I hope you guys learned something from my quick run through of Neo1.
Hey, Dan, we have a few minutes here. I'm not sure. I know we have about 5 guests, in the
Sure.
building. If anybody would like to ask a question, pose a question, now is the time to do so. We have about 3 or 4 minutes remaining. If not, you can find Dan here at the communication channels at the end. Again, this is recorded. This will be listed on the Reimagine 2020 website under the Neo workshops. So if you miss anything, you can always go back there. As of right now, do we have any questions? Feel free to, looks like we have one here.
How and where do you burn tokens? Okay, so I'm not sure. So like, what do you mean by burn tokens? Like you wanna just send them into the ether? I can tell you how you burn tokens. You send them to an address that you just kind of come up with. Like go generate an address and send them there, and then the tokens are gone. Burning tokens in blockchain terms essentially just means forgetting about them. Any like when you have a wallet with tokens in it, it isn't like there's no physical thing connecting your wallet with the tokens, right? The wallet is just kind of like an aggregated representation of all of your inputs and outputs on the blockchain. So if you want to get rid of those tokens, all you need to do is, I don't know, just kind of send them into the ether. Like there isn't some special contract you need to use to burn the token.
Great. Yeah, so I think if nobody jumps in here, I think we're all good. Dan, thank you so much for joining us today and taking time out of your day to put on this workshop. Again, we're going to be having this blasted, so I think everybody will enjoy it. And if you haven't visited the conference, Neo has an interview as well. The YouTube link is on the website. Go ahead and view that. And if that's it for today, appreciate everybody for joining. Thank you, and hope everybody's safe moving forward.
Awesome. Thanks for having me on.